Hello, I'm very glad to welcome you in this new lesson. The lesson of today is as usual mathematics as a subject, and me, I'm Felix Twagirayezu, a math subject tutor in TTCs. I wish you to enjoy for the lesson of today. Thank you. Welcome everybody. As I told you, the subject is mathematics, and this lesson is designed for year 2 science and mathematics education, year 2 SME, and this lesson also is designed for TTC students, teacher training college students. And my name is Felix Twagirayezu. I said down there are contacts. If you have any comments, any question, any support, you are free. Welcome on. Now, the unit of today is unit 5, which is functions. And the lesson of today, we are going to learn together the domain of definition of polynomial and rational function. By today, I wish and I hope that referring to the given examples in this lesson that we are going to deal with, every participant, you will be able to find out the domain of definition of polynomial functions and also the domain of definition of rational functions correctly. Now let us start. Here we have the figure. It is not new for you because we have seen it, we have used it in the last lesson. Now, considering this figure, it is a figure of Venn diagrams which are containing the elements, where set A is the set of elements and set B is the set of images. We have learned about the domain of definition, the range, and the mapping. Now, use this diagram to answer the questions below. And the question is asking what is the definition of the domain of definition, or how do you mean by the domain of definition of a given function? You remember? Think critically, and you remember that last time, the last lesson, we have seen and we have studied about the domain of definition, and we have defined it. Now, let us do it together. Remember that the domain of definition is the set of all elements which can have images, and this means that the elements which are not belonging in the domain of definition set, they are not having the images, and the elements which have no images, they are not belonging in the domain of definition. And what we have to know now is that the set of all real numbers is the biggest, the largest, or the main domain of definition set. The other domain of definition are a subset of this set of all real numbers. Now we have the domain of definition of polynomial function. We start on polynomial function. And what you have to know again is that the domain of definition of polynomial functions is always the set of all real numbers, or R in brief. This means that every element or every real number assigned to x or to y, to any variable, it will have the image. We have some examples here. We have example number 1. The example number 1 here, it is the function, and this function is f of x is equal to 2x power 5 plus 3x power 4 plus x power 3 minus x squared plus 5x minus 10. Then we have to find out the domain of definition for this function. As we said, the domain of definition for polynomial function is always the set of all real numbers. Means that also the domain of definition for this function, as we can see, it is a polynomial function because it is written in a linear form. A linear form, it is not like a fraction, it is not like it is not containing the root. So it is a polynomial function. That is why its domain of definition will be the set of all real numbers, or from minus infinity up to positive infinity exclusive. This means that every real number assigned to x, you will have the image, and in that case means that every real number, it can have the image. That is why the domain of definition for this function is the set of all real numbers. We have example number 2. F of x is equal to x power 3 plus 1. Domain of definition, as it is a polynomial function, it is written in a linear form. It is the domain of definition. It is R, or the set of all real numbers, or from minus infinity up to positive infinity, to be written as in interval form. Now we have B. We have B. The domain of definition of rational functions. We have an activity here. Consider the following functions and calculate their numerical value at the given value of x. Then, after getting that value, you think critically. You think about those answers that you get. Number A is f of x, which is equal to 1 over x. Then you will replace x by 0. Then you will get the answer, and that answer you think about it. Number B is f of x, which is equal to 2 plus x over x minus 3. You find, you replace x by 1, x by 2, and x by 3. For number C, f of x is equal to 2 times x minus 1 over x minus 1. Then you replace x by 0 and x by 1. For D, f of x is equal to x plus 1 over x squared minus 1 at you will replace x by minus 1, x by 1, and by x by 2. Finally, on number A, f of x is equal to 2 times x minus 1 over x squared plus 1. You replace x by minus 1, x by 1, and also replace x by 2. And then you will get the respective answers and you think about them. You think about them. Now, I think you have done well. Now let us see together the findings. For A, I think at x which is equal to 0, you have calculated f of 0 which is equal to 1 over 0 which is equal to plus infinity. And remember that plus infinity or minus infinity, they are not real numbers, and that is why they are excluded. Means that at x which is equal to 0, it has no image in the set of all real numbers. For B, we are asked to calculate f of 1, f of 2, and f of 3, and then we discuss or we think critically about the answer. And you have seen that the other numbers have the image, but at x which is equal to 3 has no image in the set of real numbers. Means that you have gotten plus infinity. At x which for C, at x which is equal to 1, it is where we don't have the image, but at x which is equal to 0, we have the image. Means that for C at x, it is where only we don't have the image. At D, for D at x which is equal to minus 1 and 1, we don't have the image, but for x which is equal to 2, we have the image. For E, we have replaced the x by minus 1, x by 1, and by x by 2. We have found that they have the image. Means that for every value which are given, we have the image. What we can say about this? For every value which has no image, in this case, we say that this value is not belonging in the domain of definition. Therefore, let us try to find out the domain of definition for the given functions from A up to E. For A, f of x, we have calculated that f of 0, and we found that it is giving plus infinity, where we said that 0 has no image in the set of all real numbers because infinity is not a real number. In this case, the domain of definition will be all real numbers except element 0, because 0 is the one which has no image. In this case, we write it like this: R minus a set containing only one element, which is 0. In the interval form, can write from minus infinity up to 0 exclusive, union from 0 excluded up to positive infinity excluded. For B, we found that the element 3, the number 3, if it is assigned for on x, it is not having the image. Means that the domain of definition will be all real numbers except the number 3, the element 3, and in interval form it can be written like this. For C, we have found that element 1 is the only element, which has no image, and the domain of definition will be R except element 1. The interval form can be written like this. For D, f of x, which is equal to x plus 1 over x square minus 1, we have found that element minus 1 and 1 have no images respectively. Means that the domain of definition will be the set of all real numbers except the element minus 1 and 1. In interval form, it can be written from minus infinity up to minus 1, union from minus 1 up to 1, union from 1 up to positive infinity exclusive. All boundaries are excluded. For E, every real number has a defined image. Means that no real number can be assigned to x so that it cannot have the image. In this case, means that all real numbers here replaced by x will have the image. Means that the domain of definition in this case, it will be the set of all real numbers, or in interval form from minus infinity up to positive infinity. Now, referring to the examples given above, what can you say about those examples? In this case, you can see that the domain of definition for rational functions is the set of all real numbers except or removed the values which are making the denominator parts to be equal to 0. Hence, as a summary, can say that the domain of definition of rational functions is always the set of all real numbers removed the zeros of the denominator parts. The values which are making the denominator part to be equal to 0 are the values to be removed from the set of all real numbers. I think this one is understood. It's very simple. We have the other examples here related to this rule written in red color. Now, find the domain of definition of the following functions. we have example number 1. F of x is equal to x plus 5 over x minus 9. Here we have what you call the condition of existence, so that the function is defined everywhere. In this case, for relational functions, the denominator part must be different from 0, or the x, in this case x minus y 9 must be different from 0. That is why x must be different from 9. In this case, the domain of definition will be all real numbers except this number 9. The main definition will be R minus a small set containing element 9. In a linear form means that from minus infinity excluded up to 9 excluded, union from 9 excluded up to positive infinity. For example number 2, we have f of x which is equal to x minus 1 over x squared plus 7x plus 12. In this case, the condition of existence is always the same. We take the denominator part must be different from 0. And then we are going to find out the values which are making this denominator part to be equal to 0. And those ones are the ones to be removed from the set of all real numbers, and then we will get the domain of definition. To find out the values which are making this denominator part equal to 0, if we have quadratic inequality like this, we can use any way that we want. We can use either delta, we can use the grouping, we can use any way that we want, but in this case we have used by factorization. We know that x squared plus 7x plus 12, by using any way, it is equal to x plus 3 times x minus 4. And we have found that in this case, the values which are making the denominator part to be equal to 0 are minus 3 and minus 4. Means that if x is equal to minus 3 or x is equal to minus 4, this denominator part will be equal to 0, and this function which is given here will not be defined. That is why in the domain of definition we take the set of all real numbers except the element minus 4 and minus 3. And in interval form we can write it from minus infinity exclusive up to 4 excluded, union from minus 4 up to minus 3 excluded, union from minus 3 up to positive infinity excluded. Example number 3, f of x is equal to x power 7 plus 8 over x squared plus 4. As we did in the two examples above, condition of existence is that the denominator part must be different from 0. You can see that this one is the quadratic inequality. We are going to find out the value if we can have the values which are making the denominator part equal to 0. You can use any way, grouping, delta, factorization, and so on. But for this example, we have chosen to use the delta, and we have calculated it, and then we found that it is equal to negative 16. And remember, when we were dealing with solving quadratic equations using quadratic formula, which is the delta or determinant, we have seen that when determinant is less than 0, delta when it is less than 0, or when it is a negative number, in this case we say that there is no real root or no real solution. In this case also, means that there is no real number can make x square plus 4 to be equal to 0. Means that x square plus 4 is always different from 0 for any real number can be assigned to x, or the domain of definition will be all real numbers except nothing, means that it is all real number or from minus infinity up to positive infinity. Now, after getting those examples, we have applications or exercises. In those exercises, you are going to work on them carefully, and I hope you will do them successfully. We have question number 1. Find the domain of definition of the following functions. We have function number 1, which is x power 6 plus 2x minus 10. Function number 2, we have f of x, which is equal to 5x plus 7. Number 3, f of x is equal to 3. Number 4, f of x is equal to 0. Number 5, f of x is equal to x plus 9 over x square plus 5x plus 6. Number 6, f of x is equal to x square plus 12 over x square minus 9. Number 7, f of x is equal to 2 over x square plus 2x plus 1. Number 8, f of x is equal to x over x square plus 12. Those are the 8 functions. You will find out the domain of the definition of those functions by using the skills that we learned above. Let me give you time to think about and to work about them, and I think you will do them successfully. Then we are going to have a break. We'll come after a bit.
Dufasha kwese imihigo vuba Rwanda yacu izatera imbere icyiciro cyo kwegereza abaturage ubuyobozi n'ikijyana no kubegereza ubushobozi Rwanda yacu izatera imbere turinganiza urugero rw'iyongere bw'abaturage bukajyana n'ubw'umusaruro wacu Rwanda yacu izatera imbere abaturage ku bwinshi ariko ubutaka bwo ntibwiyongera namba Rwanda yacu izatera imbere nitwita ku mashuri mbonezamirire indyo yuzuye igakwira mu miryango yose Rwanda yacu izatera imbere nidutura mu midugudu twesega abanyarwanda ibikorwa remezo biza tugeraho byoroshye Rwanda yacu izatera imbere turwanya ibiyobyabwenge mu rubyiruko tukabatoza kwihangira umurimo Rwanda yacu izatera imbere turwanya ikuza ababyeyi bapfa babyara ndetse n'abana bakiri batoya Rwanda yacu izatera imbere barireba abana yuko kandi n'udukwana abanyarwanda twese umutima umwe wo gukunda igihugu no kugikorera twese mu muntu umwe igihugu kimwe icyerekezo kimwe dukora n'igipime Rwanda yacu izatera imbere kugaganwa bikorera ndababonamo imbaraga nidushyira hamwe tuzagera
I think you have worked on the application or exercise. Let us see together your findings. For the question number 1, the domain of definition, as it is a polynomial function, is the set of all real numbers. If you have done it successfully, put your hand up. For equation, for function number 2, also it is a polynomial function. The domain of definition is the set of all real numbers. If you have done it successfully, put your hand up. For function number 3, f of x is equal to 3. Also this one is a constant function. Also every real number will have the image, which is 3, means that this one is having the domain of definition as the set of all real numbers. For the function number 4, it is the same as number 3. Every real image, every real element or number assigned to x will have the image which is 0, and the domain of definition will be the set of all real numbers. For number 5, the domain of definition will be the set of all real numbers except the numbers which are making the denominator part to be equal to 0. I think for this function number 5, we have found that the numbers -3 and -2 are the ones to make the denominator part to be equal to 0. In this case, the domain of definition is R except or minus a set containing element -3 and -2. For function number 6, I think you have seen that the numbers which are making the denominator part to be equal to 0 are -3 and +3. Means that the domain of definition will be the set of all real numbers except element -3 and 3. For number 7, the numbers which are making the denominator part to be equal to 0 are, we have double, it is only -1, means that x1 is different -1 and x2 -2 different from -1, means that the domain of definition will be set of all real numbers except element -1. For number 8, I think you have tried to find out the values which can make the denominator part be equal to 0, and I think you have found nothing. If you have used delta, you found that determinant is negative. In this case, the domain of definition for number 8 is the set of all real numbers except nothing. Means that the set of all real numbers is the set of all real numbers or from -infinity up to positive infinity. If you have done the 8 functions successfully, put your hands up. Bravo, congratulations. Now, we can end by here our lesson. This is the end of our lesson. I appreciate your attention, please. Thank you. And don't forget to subscribe. Try to subscribe so that you will get our lessons at the same time they are put out. Thank you, and we will meet for the next lesson. I wish you the best. Thank you.